Texas Math Mundo audience. Today we have an addition to our instructional series. The topic, direct variation and inverse variation working in tandem. Before we get started, let me take a quick moment to ask that if you enjoy my content, that you please hit the subscription button and the notification bell, that you leave a comment below, and that you smash that like button. I got plenty of wonderful things in store for this channel, and I truly appreciate your support. Okay, without much further ado, we have direct variation, inverse variation working in tandem right ahead. My name is Saul Cantu, and this is Texas Math Mundo. Okay, so we start off with a definition of direct variation. A direct variation is said to exist between y and x if the governing equation is of the form y equals k times x. Oftentimes, a very typical type problem is they'll give you a full point, an actual point that satisfies the equation. You would use that point to plug in and solve for k, your constant of variation, and then they'd give you a partial point. Either the x is missing or the y is missing, and you'd have to solve for the missing part. So that's a direct variation. Notice that for all ordered pairs x, y that satisfies this direct variation, if you solve for k, the constant of variation, it would be y over x. So you can immediately solve by just putting y1 over x1 equals y2 over x2 and solve for the missing part by creating a proportion. Okay, so that is a direct variation. All right, our next definition is the inverse variation. An inverse variation is said to exist between y and x if the governing equation is of the form y equals k divided by x. Again, a very typical type problem is they might give you a complete point, an x1, y1 ordered pair that satisfies the inverse variation, and then they give you another partial point, say an x2 and maybe missing the y component, and you'd have to solve. Well, you'd plug in the first point to solve for k, and then you'd be able to solve for your second one. Note that all ordered pairs that satisfy this inverse variation, since if you solve for k, the product of y and x would always equal k. So you could quickly solve by doing y1 times x1 equals y2 times x2 and just solve for the missing part. So that's an inverse variation. Okay, in recent years, I've seen some recent tests that often use inverse and direct variation working in tandem. So what the problem will do is they'll say one variable varies directly with another variable, say y varies directly with x, but inversely with yet a third variable. And what will happen is they'll give you a point, an ordered triplet that makes this true, x1, y1, z1. And again, similar to the inverse and direct variation working in isolation, you can plug it in and solve for your constant, and then you have the governing equation. And then they'll give you a second scenario, and which maybe they have an x2 and a z2, but you have to find the missing variable, and either one of these could be missing. So I've noticed an uptick of these type problems in the UIL exams, and that's what we're going to do. We're going to look at a few UIL problems that will have inverse and direct variation working in tandem. That right ahead. Okay, so the first problem we want to look at is from this past year, the Regional Mathematics Exam 2024, number 7. And the problem states that the frequency of a vibrating string fixed at both ends varies directly as the square root of the tension of the string is under, and inversely as the length of the string. So the frequency varies directly as the square root of the tension divided by the length of the string. Okay, so they give you three variables. We have the frequency, we have the tension, and we have the length. Okay, and so they're going to say when the tension is 80 newtons and the length is 75 centimeters, the frequency is 512 hertz. So they give you a full point that we can plug into our equation to solve for k, and then they ask what is the frequency, so we're trying to solve for the frequency, if the tension is increased to 96 and the length is decreased to 60. So first we're going to use the full point to solve for k. So when the frequency is 512, the tension is 80, the length of the string is 75. Solving for k, we'll get k is equal to 512 times 75 divided by the square root of 80. And so now that we solve for k, we can actually get the new frequency we're solving for. So the frequency is equal to k, which again is 512 times 75 divided by the square root of 80 times square root of the tension, the new tension is 96, divided by the new length, which is 60. So we plug this into the calculator and we should get our answer. So let's go ahead and do that. Go to the TI Inspire, and on top we have 512 times 75 times the square root of 96, and then on bottom we have square root of 80. Am I gonna square root of 80 times 60, and our answer is 701.085, 701.085, which to the nearest whole number is 701. Our answer is E. All right, the next problem we'd like to look at is from the year 2023, the UIL-B release number 25. And it states, on Riho's farm, the number of cows varies inversely as the number of pigs and directly as the number of chickens squared. So the number of cows, I'm going to use C, varies inversely as the number of pigs and directly as the number of chickens squared. Well, we can't use C for chickens because we already have C for cows. And K is what I use for my constant of variation. So I'm going to go ahead and use N. And it varies directly as the number of chickens squared. So we have the following. We have cows, we have pigs, and we have chickens. So let me just remind us. Cows, pigs, and chickens. And they go on to say, when there are 400 cows, there are 20 chickens, and 40 pigs. So they give us a complete point, a complete triplet point. How many cows will we have? So you'll be searching for cows when there are only 4 pigs and 16 chickens. So we're going to use our complete point to solve for K. Then we'll have the governing equation, and then we can use that to solve for the number of cows under the new circumstances. So solving for K. So when there are 400 cows, you got the number of chickens squared, so it's going to be K is times 20 squared, divided by the number of pigs, which is 40. So we can solve, so it's going to be actually 400K divided by 40, so that's going to be 10K. So 400 is equal to 10K, dividing both sides by 10, K is equal to 40. And so now we got our constant, and so the number of cows is equal to 40 times the number of chickens squared divided by the number of pigs. And plugging in to solve for cows, we've got cows is equal to 40, and chicken squared would be 16 squared over the number of pigs is 4. So the 4 and the 40 make 10, so C is equal to 10 times 16 squared. And for you number sense people, you should know 16 squared is 256 times 10 is 2,560 cows. And our answer is E. All right, so now it's time for you to show what you've learned. I'm going to go ahead and read. The next problem you'll look at is the year 2024, this past year, district number 19. What I'll do is I'll read the problem and I'll ask you to pause so you can attempt it. And I'll fast forward through all the work to see if your answer agrees with mine. So 2024 district number 19 says, the frequency of a vibrating string fixed at both ends varies directly with the square root of the tension the string is under and inversely with the effective length of the string. A string that was initially under a tension of 60 newtons with an effective length of 42 centimeters produced sound with a frequency of 512 hertz. What will the frequency be if the tension is increased to 120 newtons and the effective length is reduced to 36 centimeters? Okay, so this would be a good time to pause. I'm going to go ahead and fast forward through my work and see if your work agrees with mine. And so the answer is E once you plug it into the calculator. All right, The final problem I'd like you to try your hand at, and I'll fast forward through my work to see if our answers agree, is from the year 2023, the UILA release number 27. I'll go ahead and make a statement of the problem. It says the pressure of an ideal gas varies directly with the temperature and inversely with the volume. The value of the initial state were 2.0 atmospheres, I believe that's the unit for the pressure of a gas, 6 liters and 300 kelvins. What will the pressure be in the final state if the volume is reduced to 2 liters and the temperature is increased to 500 kelvins? All right, so go ahead and pause your video at this point and attempt the problem yourself, and I'll fast forward through my work. This is a good time to pause. Let's take a look. And your answer is B. Cool. All right, Texas Math Mundo audience. That is my treatment of inverse variation and direct variation working in tandem. I hope you learned something. Before I send you off, let me quickly ask that if you enjoy this content, that you please hit the subscription button and the notification bell, that you leave a comment below, and you smash that like button. I got plenty of wonderful things in store for this channel, and I truly appreciate your support. My name is Saud Kantu, and this is Texas Math Mundo. Farewell, farewell.